Just a quick note about some of the homework questions. It'll ask you to find left-hand endpoints, right-hand endpoints. It'll ask you to find a, what do they call it, an upper sum and a lower sum. So just graphically, I'm going to show you what those mean. So in this case, I think I'll use just 3 rectangles. So then let's start with a left-hand sum. For a left-hand sum, if you've got 3 rectangles, you cut up the x-axis into those pieces. So now I'll be able to cut that up. And if we're actually finding delta x, that would be b minus a divided by 3 would be the width there. But that's not the point of the question. Point is, if we were to draw left-hand endpoints, what would this look like? This would be left-hand, left-hand, left-hand endpoints. So notice I'm using the left-hand y values for each of those. If I were to use a right-hand sum, now if I draw my vertical lines here, now for the first rectangle, there's my right-hand sum. For the next rectangle, right hand, next one, right hand. So that would be a right-hand sum. If I wanted an upper sum, now I need to make sure my rectangles are above. So what would be above? That would be the maximum of this interval. So I'd have to go up to the top there. Over here, to keep everything above, would use that left point here. And then over here, I would have to use that right-hand point. So each of my rectangles takes the maximum y value in its interval. So that would be an upper sum, and then a lower sum would work the same kind of way, except you would keep each of your values to be the minimum in the interval. So there's the keep the minimum, the minimum, the minimum. So that would be my lower sum. If your curve is always increasing, like our very first example of x squared, then a left-hand sum would also be a lower sum, and a right-hand sum would also be an upper. So again, those all work out to be equal when we take the limit as n approaches infinity, but some are just easier to calculate than others. And I'm typically going to go with just a right-hand sum.